6.2b, inverse functions, continued from yesterday. It says state if the given functions are inverses. Now that's a little bit different question than yesterday. Yesterday was find the inverse. Today is state if they are inverses, and we're going to handle it slightly different. Now, what you could do, I suppose, is find the inverse of f of x, and if it happens to match g of x, then yes, they are inverses of each other. So that's one thing that you could do. But the actual way that you're supposed to do it is different. So what you're supposed to do is you're supposed to see if f of g of x equals x, okay? And so what that means is if you plug in the g function into the f function, all the numbers cancel out. And that's kind of what an inverse does. All the numbers knock each other out. So see how you see a times 3 and a plus 2? Hopefully you would see a divide by 3 and a minus 2 in the other function. All right. Now, sometimes you can just kind of tell and you can just kind of see it, but those functions, I think, are going to knock each other out. Now, the kicker, and I vividly remember as a student missing this, is you have to check it twice. You have to plug G into F, and you also have to go backwards and plug F into G. All right, you have to do it both ways. And so you have to kind of do the problem twice. You have to plug in twice. So write small, I'm not sure how much room we have here. I'm going to start with this first function, and I'm going to put G into the function. And so the f function literally says 3 times something plus 2. Okay? That's what the f function says, 3 times something plus 2. Well, what are we going to plug in? We're going to plug in the other function. And so we're going to plug in the g of x, or g of x is x minus 2 over 3. We're going to plug in x minus 2 over 3. So what we're doing is plugging a function into the other function. And hopefully all of the numbers are going to cancel out. That's what inverses do. So if you had to simplify this expression, you simplify this expression, okay, check it out. This 3, I don't need to distribute because it's going to cancel with this 3. The times 3 divided by 3 cancel out. And so then what do we have at this point? We have x minus 2 plus 2. And you're like, well, okay. Those 2's are going to knock each other out, right? Minus 2 plus 2 is 0. That knocks out. And so I'm left with equals x. That's what I wanted, okay? So you put a little check mark by it or something, but that's exactly what you wanted. All the numbers knocked each other out. That's inverses. But the problem is we have to do it again, okay? Now we have to come back through and do it the other way. So now we want to do the g function, but we're going to plug in f into the g function. Okay, so look at what the g function says. The g function says something minus 2 over 3. All right, I like when I plug something in, I like putting parentheses there. The parentheses is a good like placeholder for what you're plugging in, but it's something minus 2 over 3. And so what I will do, I'm trying to plug in that f function. So I plug in that other function, 3x plus 2. Okay. So if we're going to simplify this, well, there is no distributive property. Those parentheses don't really do anything on the top. Okay. So there's not really a distributive property. It's just 3x plus 2 minus 2. And those 2's are going to knock each other out, the plus 2 and the minus 2. And so at this point, we have 3x over 3. And you say, well, okay, at this point, those 3's knock each other out. It's a times 3 and a divide by 3. And we're left with just x, which is what we want. check, check. So to answer the question, state if the given functions are inverses. F of g of x equals x, g of f of x equals x. And so the answer is f and g are inverses. Seems like a lot of work, but it always takes me longer to explain something than it would do to actually do it. And again, the alternate method, I suppose, is just take one of the functions and find its inverse. If it matches the other ones, then they're inverses. But this is the technical way we're supposed to do it. All right, so let's go a little bit quicker for number 3. Same thing. I've got a g function, and I have to plug in the f function into that g function. So the g function says something plus 5. And if we plug in that other function, we're plugging in x minus 5. See how the minus 5 and the plus 5 are going to knock each other out and leave me with just x? Those cancel, leave me with just x. That's what I wanted, okay? So that was faster than the other one, right? Because I didn't have to explain it. For the f function, I'm going to plug in g. And so the f function says something minus 5. If I plug in that g function, I plug in x plus 5. And again, the plus 5, the minus 5 just cancel each other out. We're left with x. That's what I want. That leads me to believe that f and g are inverses. Now again, I remember doing this as a student. Okay, honestly, full disclosure, it was in college when I did this stuff. But I remember it, and I remember missing a point on this, which I shouldn't have missed, but it was because I forgot. I didn't realize I had to do it twice. All right, it's not enough just to do it once. You have to do it both ways. F of g of x and g of f of x. All right, so then number 5, you can kind of tell this one's going to be no. How? Exactly. Okay, you can kind of see the top one has a minus 5. There's nothing in the bottom one that's going to cancel out a minus 5. So I can pretty much already tell it's not going to work. But let's show our work just to make sure. So, okay, the f function, we got to plug in the g function. And the f function says something minus 5 over 2. So I'm going to plug in that g function. G was n plus 2. And if I clean up on the top, you know, the 2 and the 5 don't cancel out. 2 minus 5 is minus 3. You've got n minus 3 over 2. There's nothing else that cancels or does anything, okay? This does not work. And I'm done. I don't have to do the rest of it. As soon as you know it doesn't work, you're done, stop. So this tells me f and g are not inverses. I think number 7's too easy, so I'm going to add, I'm going to change it slightly. Let's make that 1/4 x minus 5. Okay, so just add that, change the problem. I didn't think it was quite difficult enough. And notice the directions are a little bit different. This time it doesn't say the same thing. It says find the inverse. So this is the one where we have to go through the 4 steps. Step 1, change f of x to y. Step 2, switch x and y. Step 3, isolate y. Step 4, change y to f prime of x. All right. So what do we do? This was last time. So first thing we did was change this to a y. Okay, so scratch it, you know, just write a little y on top, save some space. I didn't give you a whole lot of space. So that was step 1, change f of x to y. Step 2, switch x and y. So I'm going to go over here. I'm going to switch x and y. It'll say x equals 1/4 y minus 5. And then step 3 is the hard one. That's where you have to isolate y. Okay, that's where you have to isolate y. So there's a couple of different moves you could make. All right, either you have to knock out that 4 or you have to knock out the 5. One or the other, and everybody in here might do it. You know, you might do it this way and you might do it this way. So let's. I don't know that it really matters. If you decided to add 5 to both sides, that's going to work. But I'm going to choose to multiply by 4. Okay, I'm going to multiply by 4 here, and you multiply everything by 4, and it'll cancel out right here, but that's the only place where it cancels out. 4 times 1/4, it cancels out. That's the whole point of doing what we're doing with the inverses. We're doing the inverse operations. I'm left with 4x equals, I wouldn't say 1y, I'd just say y minus 4 times 5 is 20. Still on step 3, I'm still trying to isolate y. So here I'm kind of stuck. I have to add the 20. Add the 20 over. And I'd probably write y first, but I've got y isolated now. Y is by itself. 4x plus 20 is on the other side. That's step 3, isolate y. Step 4, just change the y back to this f prime. Okay, f prime of x, or f inverse of x equals 4x plus 20. Now keep in mind, I changed the problem. I added that 5 just because I wanted to make it a little bit harder. If that 5 wasn't there, all you'd have is 4x. Okay, because all you had to do was cancel out a divide by 4, and what cancels out divide by 4 is times 4. But in this case, we had to cancel out the divide by 4 and the minus 5. And so notice it's not a plus 5 in my answer. So you can't always just see what the answer is going to be ahead of time. Sometimes you can, sometimes you can't. But there you go. Now again, notice the difference between the two directions. Problem 1 said state if there are inverses. And then problem 7 said find the inverse. All right, now down at the bottom of the page, you've got some more review. You've got a quiz coming up Friday of this week. And so these are good review problems for the quiz. Your assignment is to finish this sheet.